Assalamualaikum and good morning to all for the students. So today you are going to study chapter 2, Matter and the Atomic Structure. Okay, our first subtopic is 2.1, Basic Concepts of Matter. Okay, so there are three things here. The first one is describe matter briefly. Number 2, explain the changes in the states of matter. Number 3, determine the melting point and freezing point of naphthalene through activity. Okay, for number 3, I will just explain briefly. Okay, because we will go into details when we do experiment in school. Okay, what is matter? So here is the meaning. Okay, matter is something that has mass and occupies space. Okay, matter consists of particles that are tiny and discrete. Discrete is separate. Okay, and the particles consist of atoms, molecules, and ions. So there are three states of matter, which is solid, liquid, and gas. Okay, the other state is plasma. Okay, plasma is an ionized gas. Okay, most stars exist as plasma. Okay, changes in state of matter. The change of state of matter is caused by heating and cooling. So by process of heating and cooling, a matter will change from one to another. Okay, so ice cream is the example of changes in state of matter. Okay, ice cream melts because it absorbs heat energy and changes from solid to liquid state. Okay, by the process of melting, so ice cream change from solid to liquid. Okay, the other example is water vapor in the air that comes in contact with cold surface. Okay, loses heat and forms water droplets on the surface. So the gas in the air, okay, change to water on the glass surface, right? Okay, so this is the conversion between states of matter. Okay, so you look at the red arrow. Okay, so it changed from solid to liquid under the process of melting. Okay, so in this process, the heat energy released. Okay, the example is like an ice cream just now, from solid change to liquid. Okay, another one is from liquid change to gas. Okay, the process is boiling. Okay, it's the same, the heat energy is released from liquid to the gas. Okay, boiling example is like you boil water. Okay, you boil water, so it changed from liquid to gas. The other process is evaporation. Okay, the example is like you hang a wet cloth, okay, outside the house. Okay, and then it will go through a process called evaporation, and the cloth will become dry. Okay, so the third one is the changes from solid to gas. Okay, the process is sublimation. Okay, the solid will straight away change to gas. Okay, without turning to liquid. Okay, for example, the mothball ni panggil ubat gegat. Okay, to prevent the cockroach. So this is in solid form. Okay, when you expose this to the air, it slowly will change to gas. Okay, that's why after a while, your mothball, okay, will become smaller. Okay, other example is dried ice. Okay, this is dried ice. Okay, it is in solid form of carbon dioxide. Okay, it is used as cooling agent and also in fog machines. Okay, at theaters, concerts, and dramatic effects. Okay, so especially in horror movie. So it will change to gas. Okay, macam ada asap-asap putih. Right. Okay. Okay, now you look at the grey arrow. Okay, from gas to liquid. Okay, so the process is condensation. Okay, for example, the eyeglass that cloud over. Okay, it happened when you wear glass. Okay, in the aircon. Okay, and then you go out to the higher temperature place. So your glass surface will have water droplets. Okay, so it means it has been through a condensation process. And then from liquid to solid is by freezing. Okay, process of freezing. Okay, for example, you put water in your fridge. Okay, the above part, so it freeze to a solid. Okay, the last part is from gas to solid. So the process is deposition. Okay, sorry, the grey arrow here. Okay, throughout the process, the heat energy is absorbed. Okay, from gas to liquid, the heat energy is absorbed. Okay, liquid to solid also, the heat energy is absorbed. Okay, anything, okay, anything that change from solid to gas would also can change from gas to solid. Okay, we will do experiment on this in the school, okay, later. Okay, so the table here is about solid, liquid and gas. Okay, so we look at the arrangement of particles. Okay, for solid, the particles are closely packed in an orderly manner. Okay, it's packed. Okay, and the liquid, the particles closely packed but not in an orderly manner. Okay, still got a space. Okay, and the gas, the particles are far apart. Okay, it's very far between each particles. Okay, the kinetic energy, so kinetic energy is like the movement energy. So in solid it's low, okay, because they cannot move. Okay, it's very packed. For the liquid, the kinetic energy is higher than solid state. Okay, but for the gas, the kinetic energy is very high, so it can move freely. Okay. Alright, attraction force between particles. Okay, attraction force between particles. So it's very strong in solid. Okay, because they stay very close to each other, so it attracts. The attraction is strong. Okay, for the liquid, the attraction is strong but less than solid state. Okay, but for the gas, the attraction is weak. Okay, because they are so far. Okay, far away between particles, so the attraction is weak. Okay, classification of matter. So matter can be classified into two, element and compound. Okay, an element consists of atom and molecule. Okay, so atom under element consists of one atom. For example, carbon, only one atom of carbon. Okay, for molecule, it contains of two or more same element. Okay, for example, oxygen, O2 means there are two atoms of oxygen. Okay. A compound, okay, compound is a combination of two or more different elements. Okay, so there are two here, molecule and ion. So look at molecule, for example, is water, H2O. So it combines with atom of hydrogen and oxygen, two hydrogen and one oxygen. So it combines from different elements. Okay, molecule under element, same element. Okay, same element. Molecule under compound, different element. Okay, combination of different element. And then we have ion here under compound. Okay, it is also a combination of different element. Okay, for example, sodium chloride. Okay, and it is ionized. Okay, melting point and freezing point. Okay, what is melting point? Okay, melting point is the constant temperature when a substance changes from solid state to become liquid at a specific temperature. Okay, it melts from solid to a liquid. Okay, freezing point. Freezing point is a constant temperature when a substance changes from liquid state to become solid at a specific temperature. Okay, like an ice cube. Okay, melting is like an ice cream. Okay, it melts from solid to liquid. Okay, so this is the heating curve of naphthalene. Okay, actually, we must do an experiment first. Okay, before we come out with an conclusion. Okay, but it's okay. I just explain briefly. Okay, but we will go into details once we do experiment. Okay, so look here. AB. Okay, AB. The temperature increases from A to B and exists in solid state. So it is in solid state. Okay, when heated, the particles absorb heat energy and vibrate faster because kinetic energy increases. Okay, so at BC, at melting point BC, the melting occurs. No increase in temperature from B to C because heat energy absorbed by the particles is used to overcome the attraction force between the particles until solid changes to liquid. So from here, it changes from solid to liquid. And then from C to D, temperature increases from C to D, exists in liquid state. Okay, when heated, the particles absorb heat and move faster. So from solid, and then here it changes from solid to liquid, and then from C to D is in a liquid state. Okay. Okay, the other one is the cooling curve of naphthalene. Okay, so we look from the above, EF. Okay, so EF, the temperature decreases from E to F, exists in liquid state. Okay, it's in liquid state. When cooled, okay, the particles release heat and move slower due to loss of kinetic energy. Okay, until here Fg at the freezing point. Okay, freezing occurs, no decrease in temperature from F to G because heat energy that is lost to the surroundings is balanced by the heat energy released when the particles attract each other to form solid. Okay, so from here EF is liquid state, and then F to G from liquid change to solid. Okay, and GH, the temperature decreases from G to H as is in solid state. Okay, now it's solid already, in solid state. When cooled, the particles release heat and vibrate slower. So our second lesson is 2.2, the development of the atomic model. Okay, alright, actually this is 2.2, not 2.1. Okay, 2.2, the development of the atomic model. Okay, so under this subtopic, you will learn to state the subatomic particles in atoms of various elements, compare and contrast the relative mass and relative charge of proton, electron and neutron, and then the atomic structure models based on atomic models of Dalton, Thompson, Rutherford, Bohr and Chadwick. Okay, this is subatomic particles diagram. So in the middle here, the pink and the blue one, okay, this is the middle part. Okay, the pink one is a proton. Okay, particles of proton. Okay, the symbol is P. The relative charge positive 1 and the relative mass is 1. Okay, and the blue particles here is neutron. Okay, the symbol is N. Relative charge is 0, neutral. It's neutral. Okay, the relative mass equals to 1. Okay, and outside here in the orbit, okay, there are orange particles and it is called electron. Okay, the symbol is E. Okay, the relative charge is negative 1 and the relative mass is 1/1840. Okay, so it is approximately to 0. It's very tiny. Okay, so here is the development of the atomic structure of model. Okay, so the first atomic model is from John Dalton, okay, 1766 to 1844. Okay, so he said matter is made up of particles called atom. Okay, an atom is the smallest spherical body that cannot be created, destroyed, nor divided further. Same elements have the same atoms. Okay, so this is Dalton's atomic model. So basically we can say that he found atom. Okay. Okay, so this is the second atomic model. It's from J.J. Thompson, 1856 to 1940. Okay, he discovered negatively charged particles called electrons. Okay, so atom is a positively charged sphere with several electrons in it. So the electron is here. Okay, as shown, the orange color. Okay, and the blue one is the positively charged sphere. Okay, so this is Thomson's atomic model. So we can say that he found the electron. Okay. Okay, so the third model, okay, the third atomic model is from Ernest Rutherford, okay, 1871 to 1937, okay. So he said nucleus is the center of the atom, okay. Discovered positively charged particles called protons in the nucleus. Almost the whole of atomic mass is concentrated in the nucleus. Electrons move outside the nucleus. Okay, so here is the model. Okay, the orange here is electrons that move outside the nucleus, and the pink one is the nucleus consists of protons. Okay, so this is Rutherford's atomic model. Okay, we can say that he found the proton. Okay, so the fourth atomic model is from Niels Bohr, 1855 to 1962, and he said electrons in an atom move in shells around the nucleus. Okay, so you see the Bohr's atomic model here. So this is the shell, okay, and the electrons move in the shells, okay, around the nucleus. Nucleus is the pink one, okay, the nucleus that contains protons. So we can say that he found a shell or orbits. Okay, shell and orbits are the same. Okay, so the fifth atomic model is from James Chadwick, okay, from 1891 to 1974. Okay, he discovered neutral particles that are neutrons in the nucleus. Okay, neutrons contribute almost half of the mass of an atom. Okay, so you see here the Chadwick's atomic model. Okay, this is the shell. Okay, the electron moves in the shell. okay, around the nucleus, and the nucleus here, okay, contains protons and neutrons. So we can say that he found a neutron. Okay, that's all for today. I hope you understand our lessons today. Okay, so today you have learned 2.1 and 2.2. Okay, you can read the textbook and other reference book to strengthen your knowledge. Okay, see you next time. Bye. Take care.